Thank you. I hope I'm speaking loud enough so that you can hear me, because yeah, because unfortunately my slides they're not like a video, so I won't be able to communicate to you directly in that manner. Thanks a lot, Sally, for introducing me. I really have it's a really great opportunity to get a chance to talk to you about some of the recent work we're doing on natural gas markets and on the potential role that shale gas can play in this rather exciting development. I'll say a word about the energy modeling form as I get into my talk. It's helpful to have a little background on it, but not a great deal. So, good. So it's working. So what's happened now is that since about 2006, in North America, we've had this dramatic increased availability of natural gas. It's at prices, at costs that people really didn't expect would happen. They're unexpectedly low. And it's generated a lot of changes in the natural gas markets, but also electricity markets, coal markets. It's really changing a lot of things going on all at once. And so we thought this would be a great opportunity to kind of take a look at this issue and to see to what extent this process is going to continue, and what are some of the obstacles in its way. And there's a lot of conclusions that people have made about this development, and we want to see to what extent we agree or don't agree with those issues. So the interesting thing about this whole development is a technology that I'll talk about very, very briefly. I don't want to spend a lot of time on the engineering aspects of it, but it's a technology called hydraulic fracturing, also known as fracking. And this particular technology is really quite different than a lot of technologies that you come across, I think, in this class. If you were doing this class back in the 70s when Jimmy Carter was a president, you'd probably spent a lot of time talking about synthetic fuels. You perhaps remember that George Bush, too, had this great push for hydrogen. And right now we're talking about a fascinating technology, carbon capture and sequestration in our global climate change strategy. But all of these technologies, it's really hard to say that they were really cost effective. They were really generating today commercial interest in this activity. But that seems to be somewhat different about the hydraulic fracturing, is that right now we're getting significant amounts of production, given what we know about this technology, and the prospects look encouraging that this will continue. Now, there are a lot of reasons why people want to slow or approach this issue carefully. And the reasons are, there's a tremendous debate going on about whether the methane leakages from this kind of drilling will be serious, so serious that some people have suggested that it's maybe not even environmentally effective, because the emissions from methane are so large they would swamp whatever kind of benefits you might otherwise get. There's another issue that people talk about quite a bit on the amount and the quality of water. Again, that's a big issue. And people have varying views on what's going on, and so that's another issue. And then finally, I think you have to admit that when you do this kind of drilling, it has impacts on local communities in ways that really do change those local communities. I often spend summers in Pennsylvania, and they're talking about it all the time. So there are some concerns there. On the same time, I think there are a number of people who have done a lot of evaluations of these kinds of concerns, and the overriding sense that I get, now I won't say that this is necessarily everyone agrees with it, but the overriding sense I get is that a lot of these concerns can be incorporated by thoughtful, well-structured policies, and that you can do that without an enormous cost to the economy. Maybe that's true, maybe it's not. But I think from some of the expert panels I've looked at, that seems to be their conclusion at the moment. So what we wanted to do was ask a more fundamental question, which was to say, let's suppose that is in fact the case, and we allowed this shale gas drilling to go ahead, as it seems to be going ahead at the moment. What kind of impact will that have on the markets? energy markets, and a few other things, environment and so forth. So that's the way to take my comments today. I won't spend a lot of time giving you all kinds of studies about what the studies on methane leakages say. It's just that it's an open issue there, but I think people are starting to come out with a conclusion that some of these things can be incorporated. So that's the nature there. And what I want to talk about are three big issues. I'm going to just limit myself to those three issues. Certainly, if you have questions on other issues, feel free to bring them up, and in the question and answer, I'll be glad to address them. But I want to ask the question is, to what extent will natural gas prices remain relatively low? Because after all, the utilities and chemical companies are really aggressively going after natural gas, or at least they are wondering about the extent to which natural gas will remain this competitive fuel, and that has a big influence on how they respond. Secondly, I want to talk a little bit about what kind of an impact this will have on the economy. It's certainly going to have big impacts on different sectors, but I think the overall conclusion that I'd like to look at is what kind of an impact does it have on the North American economy? And then finally, there's this question of, well, if we have this natural gas and it really does reduce our downstream emissions, carbon dioxide emissions, what kind of, do we really need a carbon tax or a carbon policy in all of this? And I want to address that issue too, because I think these are kind of at least three questions. They may not be your favorite three questions, but there's certainly three questions that I get asked a lot, and I thought I would just focus on that. So the process that I'm going to be talking about is something that we've organized at the Energy Modeling Forum at Stanford. And what we do is we develop a working group of different experts and advisors. These people follow natural gas, they follow energy markets, they know the concerns about the emissions, and they come from a variety of backgrounds: universities, research organizations, government, and companies. So it's a mixture of people who are pretty knowledgeable about these issues, but they bring in their own perspectives on this. And we try to facilitate the discussion through a group from, we try to facilitate the discussion from results, from models that people have run. And we've got about 14 different models in this case. And what do I do to hit this thing?
Yeah, we have to be careful you don't press the wrong button.
Did I press the wrong button?
No, you didn't.
Okay.
No, we just don't want it to like stop.
I would, yeah, I probably would get the wrong button too, knowing my expertise on these issues. So we have different modeling teams provide their results. That facilitates the discussion, and you'll see we don't try to focus in on the models as saying, well, that's the end, that's the answer. We try to use that as a discussion point, because the really interesting part about this process is start talking about what the issues are. And then I should also point out that I think it's important to say that we get support from government. About half our support comes from the government organizations, and about the other half of it comes from a variety of companies that are really interested in kind of, you're a nonpartisan research university, you're organizing this effort, you tell us what you think is the right answer. So we're not trying to do a policy piece that supports or goes against any other person's policies. So that's the kind of the notion of the process. And I should probably just say a word about the Energy Modeling Forum. We were started in, I guess it was 1976, as an effort to try to bring together a communication bridge between the people who develop the models and people who are using these models, either for policy or for corporate decisions. And we asked kind of three basic questions. First of all, should you be using a model at all for the particular issue you have? I mean, it very much depends on the issue you're talking about. Secondly, why do models differ? I mean, that's often a common problem. Oh, you get whatever answer you want. Well, they do differ for certain kinds of reasons, so that's an effort that we're trying to help educate people on. And finally, very importantly, how can you improve these models? We've got a snapshot, we've taken a look at this stuff. But what's the next step if we wanted to get to help develop the insights that I think are important? So I'm going to kind of go quickly over what I think are some kind of broad conclusions, and then maybe jump into a few of these in more detail. One of the things is we do see prices being pulled up over time. And basically what happened is you've had in the 2005 and 6, you've had all of a sudden a lot of natural gas out there, but not a lot of areas to market the natural gas. Demand was sort of a constraint on the system. We think the demand will eventually catch up and will start moving the process along. And as a result of that, we expect the prices will rise, but they're roughly in think of about a $4 per 1,000 cubic feet range. The prices will start to rise from that level, largely due to this demand development, but not totally due to that. The second thing that we really try to caution people on is that there is an awful lot of uncertainty about, first of all, about the resource base. People in the geological sciences keep telling me that we are just now starting to understand how the gas flows through these rock formations. It varies by the rock formations that you're working with. We're also, we don't know how easy it is to recover the natural gas in later stages of these projects. There's a lot of uncertainty about that. So for all these reasons, you've got to put big boundaries around this thing, and you can't really project things accurately. You just sort of say, we think it's sort of in this area. And we've got similar kinds of uncertainties on the demand side, which I'll try to talk about. The other thing is that we see certain sectors gaining a lot, and certainly the utility sector will gain by cheaper gas. The chemical sector will, oil and gas extraction will. But when you look at the impact on the overall economy, sometimes I hear that the shale gas is just going to completely overwhelm everything, and we're on a major growth path in this economy in the aggregate because of the shale gas. And I see limited evidence that that's going to be the case. I think we have to be careful on that, and I want to explain why that's the case as we go on. And then finally, I guess, the fourth topic here is on the downstream emissions. We see kind of a mixed story. We see, this is just on what I mean by downstream carbon emissions. I'm talking about where you're combusting the fuel. We do see a reduction in carbon dioxide as you're backing out coal. But then eventually, as you back out more of the coal, you're talking about backing out other types of things like, could be a nuclear plant, or maybe it's maybe the nuclear plants won't be relicensed as we thought they might be. It could be renewables, and it could be even energy efficiency. So there are a number of issues why we think it's going to be a more complex story as you go out a couple of decades. Finally, all of this assumes certain things happening on the world, the world oil market and the geopolitics of the oil market won't be major changes in that or any big major technology surprises as we're looking at this issue, or overly restricted regulations. Now, I think if you really want to, one of the ways to begin thinking about a topic, particularly like shale, is just to go and see what the Energy Information Administration in Washington says about it. They have a lot of pretty interesting information. And here's the chart that I always like to use, because this upper black area here, the shale gas phenomena, is being picked up by this black area. And it shows that since about 2006, the shale has improved dramatically. And then as you get way over here, the far right-hand corner, about 2040, you start seeing the area rather large compared to the other areas, and it's roughly about 50%. So 50% of the natural gas is supposedly, in their view, coming from this new formations. And some of the traditional sources, the conventional, what they call conventional, are these two lower bars here, and you see that declining over time. Just very simply on the technology side, very, very quickly, the conventional drilling is often, you think there, you know from your work there's a likelihood of natural gas being found there, and you end up drilling a vertical well, you break through the seal, and if you do find natural gas, you try to develop it. If you don't, then you have to go through the process again and drill another hole someplace else and find it. But that's kind of the traditional way of finding the natural gas. The oil basis, excuse me, the shale basis is a different story. I think of it more as a manufacturing type of process. I don't know if that's correct engineering-wise, but I think it's more of a process type of thing where you drill down, but much deeper, often a mile and a half deep. And then as you get into the shale formation here, in order to penetrate the rocks and to also release the natural gas, you end up putting in a lot of, along with the hydraulic fracturing, you've got the process of putting a lot of water and mud and small amount of chemicals, some of which are toxic. And you do develop but you'll release the gas, and then you just continue doing a lot of drilling down here, and you kind of going along the seam here and try to extract the resources. And based from that technology, they found that it's a lot less expensive, or they found that they can do it at today's prices pretty competitively, and it's generated a lot of interest. And also, it's shifted the gas production dramatically regionally. So the gas production traditionally was in the Southwest. That's the conventional sources were almost a lot of them were right down here or in the Gulf of Mexico. We're now finding, the shale formations, a very important shale formation up here in the Pennsylvania, Ohio, West Virginia, New York area. People are finding it here in the Colorado and Wyoming. If you extend the analysis to oil, you're finding important oil up in North Dakota, in the Bakken, and even some in California. What it means is that all this the regional dimension, what that means is that if you're going to market this natural gas, you got to expand the pipeline system to get it, and if you're going to market. Otherwise, it's just going to sit there. And so that raises another really important issue. So I'm going to talk a little bit about some energy economy models, because that's what we really used in this system. I'm going to try to give you just a rough idea what they are, because it's helpful to have some idea what they do. But I'm not going to go into agonizing detail on it, because I don't think it's necessary to get the essence of what we're doing. And the first question I think you have to ask in this particular area, and the way we're using the models, you have to ask the question, why are you using these models? What's important about them? Why don't you just sit back and just have a bunch of people come in and talk about these issues? And I think the real fundamental reason is that what happened? I've started. Oh, okay, good. Yeah, it's trying to good. So the question and I think it's nicely summarized. My philosophy of the models is nicely summarized by a statement that a famous statistician, George Box, has said, which is really that all models are going to be wrong, but some are useful. Now, what does he mean by that? He means that all models are going to be wrong numeratively. In other words, the numbers coming out of it, by definition, they're going to be wrong, because they're looking at kind of a future, and at least in the economic and behavioral side of things, we cannot project behavior precisely. So, but nonetheless, the models may be useful in help thinking about the issues. And it's not just statisticians, but famous engineers as well. R.W. Hamming says the purpose of computing is really the insights that you get out of things. It's not the numbers that you're pulling out of here. And that's very much the way we're using these kinds of models. We're not trying to project what the future is, but we are trying to get an idea of where things go based on these estimates. And the models we have in this particular effort, here's a list of them, but let me just kind of describe where they come from, the organizations that put them up. Some of them are consulting groups that have done a lot of work with governments and so forth. Some of them are government agencies like the Energy Information Administration or the Environmental Protection Agency. Other groups are research groups like Electric Power Research Institute, and various universities around. So it's a mixture of different types of groups that are involved. We actually list them out in the report, which I'll give you a citation to at the end if you want to find out more about these. But that's kind of the group of them. And basically, what do these models try to do? When you're looking at US, they're basically US models. They try to take the engineering, the technology, along with the economic side of it. And so think of it kind of, they're trying to figure out which technologies are going to be cost effective in these energy markets as we look out into the future. And basically, so one of the key things is that have a number of outside information that you need to have in order to run these models. Things like the world oil price. That's not going to be determined by the United States, but it's going to be determined outside to a large extent. Things like the baseline economic projections, regulatory policies, the resource base that you have to begin with, and how costly is it going to be to produce. That's information that is and drilling productivity. And then so that's information that's largely outside of these models, and then they take assumptions about technologies and behavioral rules of thumb and try to decide these decisions are important for making supply decisions, these decisions are important for demand decisions, and they bring them together, and what you come out of this particular model are fuel specific, that is by different fuels you get information about the energy production, the energy consumption, imports and exports, emissions, carbon dioxide, nitrogen oxide, sulfur dioxide emissions, a variety of things like that. And they will also tell you in that solution what they think the price will be when you're looking at both the supply and the demand considerations. It's the price that's consistent with both supply and demand decisions. So that's basically the kind of model we're working with. So it's sort of an economic model, but it's got, in many of these systems, they often have a lot of technology detail because, you know, realistically, if you've in this course, you know that that technology is really a key component, and that's what these models try to do as well. So on natural gas markets, the questions, now we'll just kind of ask a few questions. And as I talk to a lot of people, I think one of the things they really spend a lot of time talking about is what's available, what's the cost, and particularly when are these things going to happen? I mean, somebody making an investment, somebody making a policy, they want to know when this is happening. If it's really happening in the long run, but your focus is short run, that's not going to help you out a lot. So these are the issues that people are asking about. And when we're looking at the natural gas issue, one of the issues we look at is the natural gas price. And we've seen over the 2005 to 2012 period, prices were up initially in the $8 range. It's now, and it's fallen actually by 2012, it was actually fell down below $3. It's risen back up a little bit. And so we then asked the models to come out with projections, each one of which had very different price projections. I'll show you that in a minute. But the average price from these models show this kind of upward trend going on as demand starts to get stronger and stronger over this period of time. Now, and actually, I guess you actually get up above the $6 range in about 2030 or so, and then it continues on up. Now, this $6 is a fairly interesting number because when I talk to a lot of people in electric utilities, that seems to be the $5 to $7 range. That seems to be where there's a lot of utilities really take a lot of interest there because it starts moving you into below $5 or so. Natural gas seems like a clear winner. When you start moving into that higher range, then it starts to compete against other sources, and natural gas starts to lose. So that becomes a really important issue for them. So that's what we looked there. We also looked, and I should emphasize that this particular case is what I would call a reference case. It's based upon what the Energy Information Administration uses to develop their projections. It's based on their oil price, their economic growth assumptions. But we also said there are other types of things that can happen. And one of those things is perhaps we're more optimistic about what can be found, just in terms of amount of resources, but also about people's productivity. The people who are drilling, they space their wells differently and allows them to be more productive. Well, under those particular cases, we saw all the models showing, obviously with lower costs, you can then lower their prices, and you'll see in a minute an expansion in consumption. And sometimes the numbers get rather significant. About $2 per 1,000 cubic feet is the way they measure it. It's often a fairly big impact. And as I said before, we're up in the range of around $4 now. So that's a pretty sizable difference. We also looked at the other case and saying, you know, we could be more pessimistic about this. I mean, there are lots of arguments that people make about more pessimistic about not only the resource base, but our productivity improvements. And in that case, we're talking about this purple line here. And so that, again, is the average of all the model results. The final case we looked at, not the final, we looked at probably about 3 or 4 more cases, but we did look at several cases where we expanded the demand for natural gas. One case was through advanced technologies, but the case here is just with a higher economic growth. We were perhaps wrong in our initial assessment. Maybe instead of growing at 2.5% per year, it actually grows by 3% per year. And you see it does raise natural gas prices somewhat. Now I'm going to come back to that particular conclusion later because I think it says something about how much natural gas prices have to increase as you're expanding demand. But that number, this difference is relative, at least from this graph, it's relatively smaller than difference between here and here or here and here. And I want to come back to that in a minute. But before I do, I want to just really emphasize to you that this story here, this particular case here, that's the average. Now we're going to look at that scenario, but we're going to look at it for all the different models. And so you do start to see some big differences. And one of the key, there's several different things going on here, one of which is the amount of resources that people expect will be available at different cost levels. That really does vary quite a bit by model. Another big difference is how flexible people think that the demand will be, and how easy is it to move natural gas in and replace other fuels on the demand side. And there are a number of different factors like that, but those are 2 really important factors. So you're starting to see a range of anywhere from $5 to $7 out in the year 2030. And that also has an effect on the consumption level. Again, consumption now this is total consumption. People often use trillion cubic feet. If you're familiar with quadrillion BTUs, it's roughly 20 TCF, trillion cubic feet is roughly 20 quadrillion BTUs, or 20 quads. So if that helps you acclimate yourself, that may be helpful. And when you go across all the different sectors, you go from anywhere about 22 up to about 24, 25 now in the current market. We see gradual improvements over time as consumption starts to increase out over time. This is under the reference case. And then again, of course, the high shale case, you've got prices cheaper for natural gas, and then therefore there's higher amounts of consumption going on natural gas. Under the more pessimistic case, the costs are actually higher, and so the prices are higher and the consumption becomes lower. And then in the high growth case, you see that shoots up, and that increase in the amount due to the high growth case suggests it's as strong as some of the resource cases we considered. And it gets back to this notion that overall we think that if you have a certain amount of natural gas you're consuming and you put additional demands on it, either through increased exports or increased chemical industry activity, whatever, it's going to bid up the price of natural gas, but it won't bid it up as strongly as before if you still keep in mind the price chart that I showed previously where the prices didn't go up very much in this particularly high growth case. And then again, variation on the consumption level. It varies a lot. So basically, large amount of uncertainty, but overall we expect the demand will catch up, pushing the consumption up to maybe 25 or 35 quadrillion BTUs by 2035, currently at about 20. We think the prices will be higher than they are today, and that's important because some people are saying, well, you know, $3, $4 gas, that's a great deal. But we don't think that situation will be around long term. And then some additional upward movement as demand enters the market, but it will do so only modestly. So now we get to the story of natural gas and the economy, and there are some. Oftentimes, I see these seminars, these conferences where shale gas, the resurging U.S. economy, it's suggesting that the shale gas by itself is going to cause the U.S. economy to grow to mammoth proportions. And I just want to caution you a bit. We don't see that in our particular results. Now, we could be wrong, but let me just explain what the logic is, and it may give you a perspective on that. But nonetheless, I do want to emphasize one thing, and that is we see the impact being positive. I don't want you to get the feeling, I mean, some people look at it, I don't want you to get the idea that we're saying that it's not a positive impact. It's just that it's a modest impact is the conclusion. So what we did was we looked at the shale gas development, and then we computed over the next 3 decades what would happen each year to the GDP path. And we show, we can do these estimates of about $70 billion annually, which sounds like a fair amount. I mean, you know, that's certainly something you don't want to ignore. But when we ask the impact, what's the impact that's going to have on the economy in the aggregate, now we're talking about a $13–14 trillion economy that's growing. The impact is actually is relatively modest. I mean, it's about the GDP level, not the growth rate, but the level is about 0.5% higher, perhaps. So it's definitely positive. But one of the reasons why it's a fairly modest impact is that when you add up all the natural gas expenditures in the economy and you put it relative to the GDP, the expenditures are about 1% of all expenditures in the economy. So it's a relatively small impact. That's not to say that it's not going to have some major implications for Pennsylvania, Colorado, and some of these regions that will develop this natural gas. It will be very important for them, and it's going to be very important for the oil and gas extraction and chemical industries, and including supporting sectors. One of the things I like to do is just to kind of emphasize this issue a little more and say, let's just take a look at the growth rate in the economy since over the last 3 years. And if you look just at what's happening in the chemical industry, now the chemicals, of course, lots of people are taking European facilities and they're thinking about relocating them into the United States. You get about 8,000 jobs created over the last over the last 3 years. Oil and gas extraction adds another 36,000 jobs. But when you look at the whole non-farm sector in the U.S. economy, you're talking about 5.8 million jobs. Now, clearly, some of the jobs being created here are stimulating jobs in other sectors, but clearly the overall impact is that this sector change is relatively small compared to what's happening in the overall economy. So you'd have to make the case that this less expensive natural gas is really penetrating a lot of these different sectors and causing education and healthcare and other things to expand dramatically. And I think that's in the models that we're looking at, we don't see much of that, much evidence happening on that score. So on the question of the natural gas in the environment, which I think is going to probably, I think is kind of one of the interesting results that surprised me a little bit. But let me just make a few comments quickly on that. I guess the question then is really, do we need a climate policy after all this is? Suppose we really want to reduce CO2 emissions. Well, what's happened has been, within the electric power sector, you get coal, coal is roughly about 50% or so in 2006, and it's declined into close to the 40% over these half a dozen or so years. Meanwhile, natural gas, starting in, at the peak period, about 20%. It varies, of course, tremendously over the months, but it's about 20% here. and it's increasing and it's moving closer to 30%. So as the fuel in the electric power sector is becoming decarbonized, that you should expect declining carbon dioxide emissions, and that's in fact what we are seeing, and we have seen it already. The question is, will that continue as we go out into beyond 2020 and into the future years? And there's a bit of a more mixed story. We actually see that some of these impacts becoming on the carbon dioxide being particularly being a little less pronounced over time. And what basically happens is that after you've backed out a significant amount of coal, then for natural gas to make continued inroads, they're talking about being competitive with things like nuclear power. Now, nuclear power, what often happens is that people may decide to not relicense the plant as much, and that counts as a displacement of nuclear power in this particular case. Or in renewables, they may decide not to, if gas is competing directly with renewables, solar and wind, these new renewable facilities will not be built as quickly as would be the case otherwise. And that's what is really happening. In addition, you've got a couple of other things happening. I said we have a little more economic growth. And what does economic growth do? It raises emissions, and that raises energy consumption, that raises emissions. And you're also reducing the price of natural gas. Natural gas is often used for generating electricity, so electricity prices will actually start to fall as well, and that increases consumption overall. So for both economic growth reasons and the lower prices for fuel and power, you're starting to see increased emissions that would happen under this more shale development that would not have happened if you had adopted a climate policy. And I'm trying to rush through this fairly quickly because I realize we're getting low on time. But the basic idea here is that this just kind of gives a schematic view of the different model results in the 2035. In the electric power sector, we see the natural gas consumption, the blue bars, the positive blue bars, are displacing these negative red bars, which are coal. And that's the dominant effect that's still happening in 2035. So we are seeing that to quite a bit. But we're also seeing some other kinds of displacements in some of these models of the nuclear. This is light green is the nuclear generation being displaced, and then this green bar is the darker green bar is the amount of renewable facilities being changed. And it's interesting. A few models show renewables increasing. This is because the effect on renewables is more complex than I've talked about. It's not just natural gas competing directly with renewables, but as you're probably well aware of, one of the big features of renewables is as a backup, you want to have natural gas. Often people choose natural gas to be the backup capacity. And so you have to think of a kind of this combination of renewables with natural gas backup, and that actually gets a little cheaper because of the lower price for natural gas. And so that actually ends up in some of these models showing renewables actually expanding to some extent. But overall, in the aggregate story, you have this more complex story of where you're really starting to replace some of the both carbon-based and carbon-free sources. And I'm wondering, see, I've got almost 5. I want to make sure people.
Yeah, no, you're fine.
Okay. I just don't want to. I want to make sure that we're. So that's that's for coal and power. This is for that's for the electricity. This is the story on total energy for the different models that we have here. Again, the year 2035 is what we're taking a snapshot of this view. And again, so we've got gas displacing coal, and for the economy as a whole, we've grouped all the non-fossil sources together in this lighter green bar, and so some of that's being displaced. Notice the oil, not much of an impact. One of the things that's really quite clear is that it's having this more available shale gas is having major impacts across large sectors, but one of the sectors it doesn't really touch a lot on is transportation. for example, light-duty vehicles, we don't see a lot of people running out and buying compressed natural gas vehicles, even with these more favorable natural gas prices. Part of that's cost, but part of it's also the delivery infrastructure is not there. The one exception is in these large trucks that go across the continent, where there's lots of facilities, where the people are building facilities for natural gas. They have on board what they call is an LNG truck, a liquefied natural gas engine, excuse me, is what they have on board. And these groups, because they have the delivery, because they're driving 100,000 miles per annum easily and more, they find it attractive, and they're going to be moving in that direction. So that's the one big change in the transportation sector that we see. But overall, the oil effect is going to be, and that will back out diesel. So it does back out the diesel in some respects, but then there are other changes going on that actually increase the oil, and it's a little bit more complex story than I've talked about here. But the oil impact is really pretty small overall. And then I'll just kind of quickly move into overall on the carbon dioxide between now and the year 2035. These are growth rates, per annum growth rates along the horizontal axis. And so you get the light blue, if you can see it, is really what happens when you have a low shale world. The dark blue is really what you have with a high shale world. So that's the amount that the consumption is growing over time. So it's the big thing is that it's, across these two cases, they're pretty similar. So it's suggesting that the amount of shale gas that you have and the amount of natural gas in the system is having some impacts, but not a very large impact, particularly compared to a case where we ran a carbon policy. And the way we ran that carbon policy was, we don't know what form it's going to take, but one of the ways people talk about it as a carbon tax or a carbon fee. And this happened to be based on a carbon fee of $25 per ton of carbon dioxide. Not an outlandish type of price, but certainly a price that people notice. And then we let that price rise about 5% per year, and that's that policy. So the overall writing story here is that if you really want to affect carbon dioxide, and that's one, and as well as other greenhouse gases, you're going to need some policies other than, you can't just rely on the shale gas phenomenon, even though near term we've all seen this dramatic improvement going on. Yeah.
Can you say exactly what this is plotting? What are you doing?
Okay. This is the growth rate in the carbon dioxide between the year 2010 and 2035. So it's an annual growth rate. So this one is saying that in this particular case, it's growing about a little more than 1/10% per year, okay? And then this one is growing a little bit less, and this one is actually declining. Okay, does that help a little bit? I guess I kind of jumped. The green column, that's the case with the carbon. That's the case with the carbon price put on place of it. So the overriding thing here is that the differences between the two shale cases measured by the light blue and the dark blue is really not very big across these different cases, and you only starting to see noticeable impacts when you start putting in a carbon policy of sorts. And that has to do with the fact that the carbon policy consistently tries to discourage people from using carbon-based fuels right along. As I mentioned before, shale gas, it will back out some carbon-based fuels, but it will also back out some carbon-free sources as well. And so it has a mixed effect. And then in addition, I mentioned that there's also economic growth and greater consumption with these shale issues as well. But that's kind of the notion behind it. And so I think at that point, I probably should, I'm just trying to think, I do have one other issue. I think I've already summarized that. That's the report that I've talked about. If you do emf.stanford.edu, you should be able to get it. let me just jump through that. Some of the advantages and remaining challenges. My view on the models, by the way, is that they're half full in the sense they give you some insights, but they're half empty in the sense that there's always a lot more work that needs to be done with these systems. And so I'm going to jump through that and not bore you with that. The one issue I do want to talk 1 minute about and then get some questions here is that this question, will the U.S. exports be globally competitive? That's an issue that these models don't do very well because they're mostly North American. And but I think it's a very important issue to ask, how much natural gas could we export overseas if the government allowed that to happen? And it looks like they are allowing to happen. Well, this chart I think and it's my final chart here, I think is useful, except that oh no, it worked out fine. It's measuring the costs in what they call a million BTUs. It's roughly close to 1,000 cubic feet. These are the costs. And basically Japan, that's one of the big Asian markets, their price is linked to the oil price. That's basically what they've adopted to doing. They have a bunch of reasons why they're doing that. So that's their price that they're paying for it. And this is some future year, 2025, but it represents the problem. So that's their price. This is the United States price, and sometime in the future, $6, about 2025, that's probably consistent with our results. That's what you're paying at this field price. But if you want to get it over to Japan, what do you have to do? You have to liquefy the stuff. You make it into a liquid form. You then put it on a tanker and ship it. And then when you get it over to Japan, you have to regasify it again. And then also put in, you have to pipe it to whatever utility you want to sell it at. So by the time it's no longer $6, it's roughly above, it's almost like $11 coming close. So you're eliminating a lot of the difference between what Japan pays and what the U.S. is selling the gas for by all these additional costs that you have to put onto the market. And then over time, what's going to happen is if you start selling more natural gas from this region here, from the United States, that's going to pull this price up a bit. The Japanese price is probably going to come down a bit because they now have more natural gas, and they may decide that they don't have to pay oil-based prices. They could pay lower prices. So that's one issue. The other issue is, look at the U.S. price relative to a lot of the other prices that could be potential competitors. Look at in Africa, or look at the Middle East. These are regions that have considerably lower prices that they could sell the gas to and still make a profit into those regions. And so what's happening is the United States, where we've got all this extra gas and we've got two things working against it. One is the extra cost we have to put to get it to the regions. And the other issue is that we have a lot of competitors, people who are developing their gas now. And these people haven't even begun to get into the shale gas issue in a big time. But if you can imagine the Chinese and other groups doing that, that's going to be a lot more competition there. So I think that's a really intriguing issue. And in fact, let me just summarize by saying that it's such an intriguing issue. That's really where we're going to be spending a lot of our attention over the next year or so, is to try to evaluate that particular issue with a set of models that can actually address that particular question. So let me stop with that. And Sally, I'll let you.
Yeah, okay, I'll moderate the questions. Yeah,
Yeah.
Sorry, but we typically start with student questions.
Yes,
first.
right,
So
right.
Anyway, let's thank them for So we'll start with student questions. Okay, all right, great.
Thank you. If I'm not mistaken, our current reserves to production ratio with natural gas in the U.S. is around 13 to 14 years, and while that continually remains relatively constant as our reserves continue to grow, do you see that as sustainable for the next 30 years so we can continue to grow the use of natural gas?
Yeah, now I think so. Reserves you got to be very careful. Reserves are really what people have proved up and so forth, and that number can bounce around depending on the market conditions. I think the reserves are not the issue. I think the real question is the resource base there, and I think the resource base, looking at what I've seen, now this is resource base globally, can easily see another 100 years of our consumption levels continuing on with the amount of resources there at roughly at today's cost. So I don't see that as a major issue. Now, I will put that one caveat I put on earlier is that I think the geological sciences are really exploring that issue in more detail, and they may correct me in the next 5 years if it's much more difficult to recover this stuff. But I'm pretty optimistic that worldwide we've got quite a bit of natural gas there. Yeah, thank you.
So I'm from Puerto Rico, and we are currently the government wants to convert most of its gasoline plants to natural gas instead, and use that as a measure until renewables become more popular. Do you think that's a good strategy? Taking into account that natural gas prices are bound to go up.
Yeah, well, again, this is the question of when to do it. I think from a transitional stage, it probably makes sense to go to natural gas, realizing that people will eventually move off of natural gas as the price moves up steadily, and that's what's going to happen, I think. And I think it gives people the option to actually develop the renewables even more than they have now. So I don't find anything particularly wrong with that strategy. You know.
I heard that kind of about a year ago when natural gas prices were very, very low, most producers weren't able to actually get the return that they were seeking when they were developing new fields. Do you think that situation has changed, or are margins kind of permanently compressed for natural gas?
I think they're still under pressure today, actually, to some extent, and that's another reason why I think the prices. I mentioned before, it's not just demand increasing, but I think that's another reason why the prices will eventually move upward. A lot of the companies now are looking at this development as kind of a technology play. They want to find out more about the technology. They also have to do a certain amount of drilling when they sign a lease. But I think now some of those concerns are petering out a bit, and I think people are they won't produce in the natural gas as strongly unless they do get a higher price. And so I think people, and actually when you look at the drilling, you do see people are shifting more from natural gas onto oil. So that's another indication that they think the gas prices were too low. Yeah.
Your figures showed CO2 emissions, manipulated CO2 emissions, and it wasn't clear whether that was some CO2 equivalent or considering methane emissions.
Yeah.
Also.
No, the short answer to that question is we did not, and we did that. Well, we have a delicate balance act here. Is that within the energy modeling? This is kind of an organizational thing. Within the energy modeling stuff, I try to do stuff that's related to energy, but has some association with greenhouse gas policies. But my primary focus is on energy markets. My colleague, John Wyatt, does more of the climate change stuff. And so what we've been plotting is for him to do a similar kind of analysis, but to take into account the full things like methane leakages is very important. Now, we did have a model that did do some results on the methane, and it changes the results to some extent, but not in as dramatic a fashion. I guess he didn't really adopt Horvath at Cornell. He didn't really adapt his view on what was happening in the emissions. It was more kind of he used some different estimates on how costly it would be. So those issues were just carbon dioxide because that's really what the models were focusing a lot of their attention on in this particular study. But when you go over to John Wyatt's study, he's got more models that really do take apart this carbon dioxide and the greenhouse gas issue and goes into a lot more detail. And that's really the way you do it if your primary focus is on a more comprehensive climate policy. Okay.
We'll take two really quick questions. We'll take one up here. You had a question?
read from the short.
Oh, in here, yeah. Good. Basically, this is the cost that cost of it's the cost that the price that the producer receives when he's in the field. He's just taking the stuff out and he gets it ready to put it on to send it somewhere. That's basically he sells it into the plant. That's this price. So it varies. In other words, what it's saying is that the price in Africa is fairly low, as the price in the Middle East is fairly low. But the price in the U.S., although it's been, it's considerably higher because it's a lot more demand for that particular thing. But that's basically why that price is lower. It's a production cost, yeah. It's the cost of extracting the natural gas.
Okay, actually, we'll go over there. You had your hand up, and that's the last one. So.
Yeah, my sense is that you dismissed fugitive emissions of methane too quickly, and it's probably true that on a well-run wellhead, there was very little fugitive emissions, but we're seeing a real uptick in atmospheric methane, and there was a recent study done in Boston that showed frightening amounts. So while you may not be able to directly attribute it to the wellhead, although you might be able to, you leave the impression that we don't have a problem with fugitive methane emissions, and I think we do. Okay. So I would urge caution there. And on the economic growth, I would go in the other direction. I think we have a greater shortage of just beds for frac workers in North Dakota than you attribute to the entire industry in your little sliver there. So I think that the industry is very labor intense when you frack it compared to other parts of the versus oil or coal. And my sense is that we're stimulating more jobs than you've got somehow in your model there.
Well, I think one of the caveats on the latter issue, one of the caveats I was trying to make was that there were some of the jobs being generated outside of that sliver. But you'd have to be talking about these slivers being 10, 20 times what was being generated within the sector. And I find that hard to imagine. Now, on the first issue, in the methane leakage issue, I didn't mean to say that I thought we had resolved all the issues. And in fact, one of the things we're doing in our new effort is to try to come up with estimates of what would it cost to fully compensate everybody for all these things. Because it's very much an open issue. As you're probably well aware, the Natural Resource Defense Council, EDF had this big study on their results was suggesting that the EPA estimates may have been even too high on this stuff. And now this new stuff coming out of Boston is kind of saying the other direction. So because of all this unknown, we're trying to now get an estimate of what we think the additional costs might be involved and try to take another look at that issue and put that into the evaluation. Because it's very much a state of flux in terms of the analysis. Thank you very much.